Questions 1 to 6. Find the value of A, correct to 2 decimal places, and find the value of A. Oh yeah. So we're going to get here, guys. It's the sine rule. Sine rule is A over sine A equals B over sine B. On a really basic level, there's two types of questions. You're either asked for an angle or you're asked for a length. If you're asked for an angle, how does the question end? Sine inverse. If you're not asked for an angle, it just ends with you using the calculator and you get a length. Okay, there's only two ways it can end. You right with that, Daniel? Good. Now, what you do is this. It's really easy. You just draw the angle and you look at what side the angle looks at. What side is that angle looking at? A. So you can write down A over sine 35. Is that okay? And then next one after that? What other side do you know? 70 looks at the 8, so you can just say 8 over sine 70. Now, we did this yesterday. How would you get A on its own? So you're going to get 8 sine 35 all over. And when you get that, what's the answer? Just have the calculators handy, guys. $4.88. Okay, so that's a fairly basic type of question. Okay, so if we were to move on to these ones here. Now, the problem is this time around is that A looks at 72. That's no bother. I can use A over sine 72. Most people would do this then. Oh yeah, 6 over sine 68. Can anybody explain, have I done something wrong there or what's going on? Yes, Cameron? 6 is not looking at 68. This angle here that we don't know is the one that looks at the 6. This means that this 68 is wrong. Anybody have something we could fill in for the 68 instead? Take that away from 180 and I'm pretty sure you get 40 degrees. Now all of a sudden you're back to 40 degrees. You bring up the sine 72 and you get A equals 6 sine 72 all over sine 40. And what's that? Huh? 8.88. Okay. So guys, that leads us on to question 9, alright? Sorry, question 6. Now I want to show you a little trick. I would have shown a few of you this yesterday, okay? When you get two fractions that are equal to each other, as an example, 2/3 equals 8 over 12. If you turn both sides upside down, what happens? 3 over 2 is equal to 12 over 8. You see that little trick there? That if you have two fractions that are guaranteed to be equal, there's an equal sign in between them, you can turn them upside down if you want. So that brings me on to the next part here. This time around, the sine rule, as I wrote it and as it's in your book, is this. But there's nothing stopping you from using this instead. Now you might ask me, why would I want to do that? If it's an angle question, I do that every time. Just makes it easier. You don't have to do it, but it makes it easier. Okay? So look at question 6. I have to find out what angle. What angle do you think it's looking for? A. So we'll write down sine A. What side is the angle A looking at? 12. And the other side? Sine 130 divided by 20. Okay? You see it, everything there. Okay? Now, once I've done that, how do I finish this off? Bring the 12 up first. So sine A equals 12 sine 130 all over 20. What can we say sine A is equal to then? We'll just put that in the calculator. 12 sine 130 divided by 20. We won't round it up just yet, right? So try and put in as many decimals. 596, okay? 0.4596. Don't round it off till you actually got the actual answer for A. Do you know if the answer says round it off to 2 decimal places? Only round it off to 2 decimal places at the very end, when you have the angle, not when you have the prelude to the angle, when you actually have the angle. What's the last step then? Or if it's stored in your calculator, you could just say shift sin inverse answer equals 27 degrees, okay? So we're talking about 27 degrees right there when you sin inverse it. We just sin inversed it, and we found out for that to happen it needs to be 27 degrees. Everybody cool with that? So that's 2, 5 and 6 done so far. No, 2, 5, 6 is that. What's it for? Okay. Now, I'm pretty sure you can handle that one. It's pretty easy. Moving on. This one, number 11, be the hardest one here. Okay. Calculate SPR. The angle SPR, which triangle is it located in? The left one. Are you allowed to use SOHCAHTOA? Why not? SOHCAHTOA, it's not a right angle. It's not a right angle, so we can't use it. Now, the problem is, if I was to use this here, is I would want to use this angle against this one here, wouldn't I? That's what I'd want. My triangle to the left is lacking a lot of information. Can you guys find a way to give me more information in SPR? Farrell? Farrell's going for the straight angle. 180 minus 65 to find out what that angle is in there. That'll be 115. Then what, Daniel? $180 minus 42 minus 115 will give you 23. Now you have enough information to work your triangle now. Does everybody see that? So you got to accumulate information first, and then only then are you able to calculate your triangle. We want PR now, yeah? See PR? PR is this one here. Okay, we have to calculate that one. Now, what angle does PR look at? The side PR, we'll call it X. What one does it look at? We're going to use the triangle that has the most information. Yeah. Which triangle has the most information, right or left? You have to use the left one, because the left one is the one that has the distance in it. If you tried Pythagoras' theorem over in the right triangle, would you be able to do it? You have no information, so therefore you can't use it. You only know you know all 3 angles, but you don't know any lengths. So because you don't even have a single length in that right angle triangle to the right, it means you can't use it. It means we've got to use the triangle to the left. Triangle to the left is not a right angle triangle, so what rule does that mean we have to use? It's not a right angle triangle, so sine rule, right? A over sine A equals B over sine B. Are we doing an angle question or a length question? So we leave it the same. So we get X over sine 42 equals, you had to choose the 60, didn't you? 60 is the only length we have. Okay. What happens next? Sin 42 by sin 23. Someone want to tell me what the answer to that is? quiet, guys. 102.75 meters, yeah? So 102.75. Okay. Next one, calculate PQ. Hence or otherwise, calculate PQ. So where's PQ located? PQ is yeah, it's the perpendicular height. What triangle is it located in? The right angle triangle. Okay. So if I was to rewrite this right angle triangle, I'm just going to eliminate the old information. This is now 102.75. Looking at the right angle triangle only, is SOHCAHTOA an option? Oh, sorry, is Pythagoras' theorem an option? Is SOHCAHTOA an option? It is. You have an angle and one side. You have to. Can you still do the sine rule? Sine rule still works, but you'll need to be able to use SOHCAHTOA. You need to be able to switch between the two. So, what I'm asking you guys to do is this: look at the question in isolation. And had this been a week ago, you would have only done it one way. You would have looked at this and you said, okay, it's a right angle triangle, and you'd still be thinking in terms of SOHCAHTOA. You'd be like saying that's 102.75. That's an angle of 65. It wants you to find the opposite or the adjacent. Call the opposite. We already have a value. Call the opposite y. So we have the hypotenuse. We're looking for the opposite. What function should I use? Sine. Sine 65 equals opposite over hypotenuse. Y over 102.75. Bring the 102.75 up. And what you get? 93.12 meters. Okay. So